Hello and welcome back to Algebra, Chapter 9, Section 6. That's correct, ladies and gentlemen. This is the last section of Algebra. Alright, we're talking about binomial distributions. First off, just looking at probability distributions, we have a couple of terms that I want to define. We have a random variable. Random variable is determined by the outcomes of a probability experiment. A probability experiment is something like rolling a six-sided die. And a probability distribution is a function that gives the probability of each possible outcome a random value. Alright, so a probability distribution for rolling a six-sided die. So our x is first going to be the outcomes. Alright, so the outcomes on a six-sided number cube are 1, 2, 3, 4, 5, and 6. The probability of each one of these happening is 1/6 for each. Okay, so there's my probability experiment. Now, if I want to construct a probability distribution using this example, like the six-sided die, I can make a table that shows the probability distribution. Okay, so I want to let x be a random variable that represents the sum when two six-sided dice are rolled. Okay, two of them. So if I have a 1 and 1, then I've got 2. That's the smallest value I can do. And 6 and 6 gives me 12. That's the greatest value. And then I can get every number in between. Now there are different ways that you can, there's only one way you could roll a 2, and that's if you get a 1 and a 1. But if you, a 1 and a 1. If you roll a 1 and a 2, you can get a 3 that way, or you could roll a 2 and a 1. Get a 3 that way. 4 could be rolled with a 3 and a 1, or a 2 and a 2, or a 1 and a 3. Alright, so this is one way, this is one way, and this is one way. So now we have 3 ways here. So we only have one way to roll a 1, one way to roll a 12, 2 ways to roll a 3, 2 ways to roll an 11, 3 ways to roll a 4, and so on. Fill in the entire table, and this is what it looks like. Now the probability of each of these is out of the total number of outcomes. So if we add up all of these, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, we get a total of 36. Remember, one of the most important things to always do first is add them up, get your total. If you're doing probability, first find your total, know what that is. Now, if it's only one outcome out of 36, that's just 1 out of 36. 2 out of 36, I can simplify down to 1 out of 18, and then fill in the rest of the table with my total outcomes. This is a probability distribution. Okay, from least likely being 1 in 36, 1 in 36. So it's just as likely to roll a 2 as it is to roll a 12. To most likely, and that is 1 in 6. The most likely to roll is a 7, because there are the most ways to combine those numbers to get a 7. Like 2 and 4, 5 and 1, 3 and 4. No, I said 2 and 4. 2 and 5, 3 and 4, right, or 6 and 1. So several different ways I can get the 7. Now I could organize this also in a histogram. If I do a histogram, for my y-axis, I'd show the probability of x. So this is like a function table. I've got my x, and then the probability of x happening. So that's going to be on the y-axis. And then here, I'm just going to go up as high as I need to. Okay, you don't need to go 1, 2, 3, 4 if we're only going by fractions here. Okay, so I'm only going to go up to 1/6. And then here, for my total outcomes, I'm going up to 12. And then fill in the table. That's what a histogram looks like for this distribution. Alright, interpreting probability distribution. Use the probability distribution in example 1 to answer each question. What's the most likely sum when rolling the two-sided dice? Well, we've already found that. The most likely sum is the 7. Okay, And then what is the probability that the sum of two dice is at least 10? The sum of two dice being at least 10 means it has to be 10 or more. That's these here, and then we can add those up. So, if we add these up, I get the probability of x is at least 10. That's the probability of x being 10 plus the probability of x being 11 plus the probability of x being 12. Alright, and that's 1/12, or I can multiply that up to 3/36 since I'm adding fractions, plus 2 out of 36 plus 1 out of 36, and that's 6 out of 36, which simplifies down to 1/6, or approximately 0.167. Okay, or give that as a percent, that's about 17%. All right, binomial distributions. The binomial distribution shows the probabilities of the outcomes of a binomial experiment. All right, now a binomial experiment has to meet these conditions. There have to be n, a certain amount of independent trials. Each trial has only two possible outcomes, success and failure. So either it is it or it is not it. The probability of success for each trial is the same for each trial. The probability is denoted by P. Probability P is the success. Probability of failure is 1 minus P. All right, you'll see an example in just a moment. And we can use this formula right here. Probability of K successes is, and then we have a combination of N and K, and then the probability of success to the power of K, and the probability of failure to the power of N minus K. All right, we'll look at this in an example, it might make a little more sense. Okay, so according to a survey, about 33% of people ages 16 and older in the U.S. own an electronic book reading device or e-reader. You ask 6 randomly chosen people ages 16 and older whether they own an e-reader. Draw a histogram of the binomial distribution for your survey. All right, so first we have to make the binomial distribution. Now we're going to use our formula. So the probability is, again, 33. We'll change that to decimal, so 0.33. That's the probability of success. Now the probability of failure is the complement to that, so that's 1 minus 0.33 is going to be 0.67. That's the probability of failure. So those are going to go right here, in for P, and then failure in the parentheses here. Successes I'm going to go through. What's the probability of 0 successes? 1 success, 2, 3, 4, until I get to 6. Okay, so because that's my greatest possibility. Obviously, with 6 people, I can't have more than 6 successes. Okay, so I'll start with 0, right? So that means to the 0 power here, and then n minus 0. And that gives me a total of about 0.09, so about 9% that I will have no successes. And then I can go down the line, say if I have 1, all right, I have come out with about 0.267. If I have 2, I get approximately 0.3 or 32%, 33%, and so on. I'm going to go all the way through until I have 6. And now I can make my histogram. Okay, so if I set up my table here, again, my greatest number is 0.329, so I'm not going to have to go much higher than 0.3, and then fill in my histogram there. And now I can read from this, see which one's the greatest, and that would be 2. I can see that right here too. There's your histogram. Use the binomial distribution. What's the most likely outcome of the survey? Again, most likely outcome of the survey is that I have 2 successes. That 2A is that 2 people have an e-reader. So k equals 2 is the most likely, right? Highest there. Now, what's the probability that at most 2 people have an e-reader? At most 2 people. All right, so if we look at that, that's all of these at most. So that includes 2 and fewer. So that's 0, that's 1, and that's 2. So the probability of at most 2, probability of x is less than or equal to 2, that's at most, is equal to probability of k equals 0 plus probability of k equals 1 plus probability of k equals 2. Add those up, and that's these three right here. So that's 0.09 plus 0.267 plus 0.329. And that comes out to be 0.686. So the probability that at most 2 people have an e-reader is 0.686. There you have it, ladies and gentlemen. It's been fun. It's been real good times.